Hello guys, welcome to Pre.Code, and today we are working on this problem, that is chef and linear chess. This is a very good question, and see what's the beauty of question, right? This is a very simple question, but with the help of some words, right? And it feels like it's too much, and no one can able to solve this problem. But that's not the truth, guys. We can we can try our best. Okay, let's understand this question word by word. Chef wants to play a game of linear chess, okay, on a one-dimensional board. An infinity row of squares numbered by positive integer. In this game, he has a pawn which is initially at square k. Okay, there are also n other peoples that is numbered from 1 to n. Chef can choose one of them to play against. For each valid I, the ith player would play the following way. Okay. Take a pawn and place it on a square of pi. Okay. At that time, what's going on? There is one dimension. What is the spelling here? One dimensional board. That is array, right? We have one array, one dimensional board, and an infinity row of squares. We don't know where it will end. And then he has a power which is initially at square k. There is something called k, which is like one square, two square, three square, four square, and somewhere like that has a k, right? This is called timeline. What next? Now he say we also have n other players, right? And they are present at p of I square. Like we have some other players like two, one like player one at position no at square two. Okay. After that we have one more player, that is player 2 at square 3, right? Now we have one more player, for example, player 4 at square, no, player 3 at square 4. That's it. Now, for each valid I, the ith player would play the following way. Take a pawn and place it on a square of pi. We can do it. Then repeat the following move any number of times. Move the paw from its current square pi squares forward from square s. This player paw is moved to square s plus pi. What does this mean? If if player 1 is at square 2, that means now the next move of player 1 will also s plus pi. That means that means for 2 plus 2. This is the second move. And in third move, it go with 2 plus 2 plus 2. That is 4, and that is 6. Okay. Similarly for player 2, it will like 3, then 3 plus 3 6. Then next move will be 9, and next move will be 12, like that n times. Similarly for player 3, it will like a table of 4, 4. Next move will be 8. Next move will be 12. Okay, 8, 10, 12. Okay, now For example, okay. Unfortunately, chef cannot move its paw. That is K. That is K. K cannot move its position, making him an easy target for other players. Given the starting position of all n plus 1 players, find a player who can capture chef's paw. That is K. Each player, each player 1, 2, 3 need to capture K, right? In in minimum number of moves and determine that no player can capture its paw, right? There is a possibility that we have like k is equals to uh, uh, 11. Then whatever player one, 2, 3, any player can do anything with any possible move. 2 cannot reach 11, right? That is 2, 4, 6, 8, 10, and then 12. It jumped to 12. It skipped the 11. Similarly, for 3, it doesn't reach to 11. Similarly, for player third, he is also unable to catch the chef's paw because it's in between position where they cannot able to catch it. They will just skip that position. So in that case, we have to return -1. Okay, because all players does not able to catch the chef's paw in minimum moves. Now, what we can have to do in any other case, like k is equals to 12. Now, player 1, now listen carefully. Player 1 can catch 12, that is k, that is chef's paw. Chef paw, right? Player 1 will catch this k with 5 moves, right? And player 2 can catch 12 in how many moves? That is 1, 2, 3. That is 3 moves. And then player 3 can catch 12 in how many moves? That is 1 and 2. That is 2 moves. So we need to return what? The smallest number of moves. Okay. Find a player. Find a player who can capture chef's paw in the smallest number of moves. That means what we have to return. Uh, there are three possibilities to catch 12 by n players, but here the minimum moves we found is 2 moves. For which player? That is third player, right? So we have to return that specific player who can catch the K in the smallest moves. Hope you all guys can understand the problem. Now we can go with the code. For example, the player who starts at position 2 can move to the square 4 and then 6. Right? 2, 4, 6, 8, 10, 12. The player who starts at position 3 can move to square 6. That is 3, 6, 9, 12. And then the player at position 2 can capture K in two turns, whereas the player at position 3 can capture chef's paw in one turn. Therefore, the answer will be 3 because minimum steps required to catch chef's paw is 1, which is by which player? The player at position 3. So we have to return that position. Ayyo. Okay, let's go and solve the code. Okay, now we can start it. Firstly, we have to take variable t which represents the test cases like c in t while t minus minus. Now it will iterate all over the test cases like 1 then 2, right? So we have to see the output. For each test case, print the single line containing one integer. Okay. The first line of input contain t. Okay. The first line of test case contain two space separated integers n and k. Okay. Okay. The second line contains n space separated integers of players. Okay. Int n comma k, where n represents the number of players and k represents the position of chef's paw. Okay, that's it. Now we can also able to define one vector of int vector of int, that is p, that is player player's position. I think it is a suitable name for that variable. And then we have, after taking input, n has some value and it will generate that size of vector. Right now we will take input for this, int I is equals to 0, then it moves to the last position, that is n. Then we have to take input for the player's position, that is fi. Okay, now we have that now we have to simply think like this, that if the chef's position is completely divisible by the initial position of the player, that means it is like completely divisible, like 12 divided by player 1's position, that is 2, we get 0. That means 12 is reachable somewhere, right? Then for next player we also similar concept like 3, we can able to catch the 12 by player whose position is 3, right? Similarly, if we have a player like 5, right? So as we know, 12 is not completely divisible by 5. It will remain some remainder. That means the player at position 5 cannot able to catch this uh, chef's paw, right? So we have, what we can do, we have to iterate over an array, iterate over our player's position, and what we can do, if if k modulus k modulus uh, player's position I, and it will return 0, then we have to decide something, right? Like that means player can compatible to catch, right? uh, and for all other players we does not calculate anything. But next, now we have to find the moves. So we can also find the minimum moves, like we can take vector of int for min moves. We can take this, right? Then we can capture the min moves like 12 divide by 12 divide by player's position, that is I, and minus 1. Right? I think now we will get the minimum moves. Now it is also possible that if chef's paw is at position 1, at square 1, right, and players are at position something like 4, and one player is at 7, one player is 8, right? Then K is smaller than these players' position. So this is also written in the question that everything will be goes in forward direction. Somewhere I'm not able to find that word at that time. Unfortunately, chef, okay, and times. Yeah, then here it is. Repeat the following move of any number of times. Move the paw from its current square pi squares forward only. Right. So these player will move to next positions, not in the back back way. So for that, we also have to put one more condition, that is K is greater than or equal to player's position I. Right? I think now it works perfectly. Okay. Now we have the minimum moves by each player who are compatible. So now we need to find the mm, minimum moves for that player. How we can find that thing? We have I, right, right, right. So now we need to make one more variable, that is min, no, best moves. Okay, that is int max. Int max. Now int I is equals to 0, and iterate over this I plus plus, and then if best moves, oh sorry, best moves and min moves, then uh, best moves will be min min moves. And now we have to return not the moves, we have to return that player's position, right? So I think we need to make one more variable, uh, winner player. Winner player, that is 0. Now the winner player will be player position of I, and this is the fucking answer. Hope so it works. Let's run it. What they will do. K player. Okay, okay. My mistake, my mistake. Mm, this is our language. This is not C++. Output will be 4 and 4. Mm, 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 mm. Min moves. Min moves. Min moves. What we can do now? Why it will give the wrong answer? Okay, okay. It gives us. I think so. What is the output for this? 2 4. Okay, okay. 3 and minus 1. 3 and minus 1. 3 and minus 1. Min of I. Why we are taking this? And then we can find. I think we don't need to take this, Harry. Just variable and moves and remove this. Okay. And if that moves are lesser than best moves, then update the best moves to with the moves, and winner player will be that is minus 1, and winner player will be player position at I, right? And we need that position, and after that we can not do anything. Okay, we can run this. Run it. Okay, I'm so sorry. That's it. I think now we can solve this problem. Okay. Start submitting. Ooh, wow, looks great. And now we can also able to see other approaches, right? Like go to the solutions, missions, explained very well. That is 2 star, right? What they will do. Taking a vector and then taking input, sort them, reverse, result minus 1, break. At at that time, I'm not saying anything. We will also find the uh, good solutions in the comments too. You all guys can also do your best thing and try to connect with me in the comments. If there is more optimized solution, we will get. Thanks. Have a nice day.